Hi everyone, my name is Dave Nielsen. I'm with Redis Labs and I'm here to talk to you today about Redis in general. I'm also going to talk about my favorite things, which are Redis commands, or some people call them functions, and data structures. And in particular, at the end I will be talking about Redis Streams. I hope to spend quite a bit of time on that, but I always like to make sure we have the basics of Redis functions and data structures down. So pretty simple agenda, lots to cover. So I'm also going to help you understand a little bit about Redis Labs. So let's get started. First of all, I want to ask you all, how many of you have used Redis? Maybe 20%, okay. How many of you feel like you understand what Redis is? So those plus a few more maybe, okay, maybe 40%, all right. So some of you are new to Redis, and so that's why I have the first half of the talk is actually more targeted those who are new to Redis. The first thing I want to ask you is, would it surprise you to know that according to at least this one survey that was done 2 years ago, and then actually there's another one that just came out this past year, Redis is either the #1 or #2 most popular database on Amazon. Would that surprise? How many of you, raise your hand if that is a little bit surprising? Just a little bit. Raise your hand. It's fine. Yeah, lots of you. Okay. So it should be surprising because when folks first start out with building their application, it's actually quite uncommon for someone to just say, okay, I'm going to start my application and I only need Redis. That's actually unusual. Some people do it, and there's good reason to do it. There's a lot of game companies out there and other social media applications that use only Redis or primarily Redis. But for most people, it's probably not the first thing you would think of. But you should, or at least many people do. But let me explain this survey. Most of the time I ask an audience, in fact, we'll ask you, if you were going to build an application, your next application, would you first start off with Redis? Raise your hand. I kind of gave away the punchline already there, but yeah, it's not that common. So how could it be the most popular database on AWS? Well, here's why. Because most of the time, companies or developers, they're going to start off with an easy to get started database like a SQL database, something they're familiar with, and there's lots of those. And there's also MongoDB, there's a couple other options out there which people consider to be like their primary database. And that market is very competitive. There's tons, Redis is in there too, of course, and there's tons of people who are options there. And according to many surveys, the most dominant player might be MySQL at about 13% of the market. So fairly small. But as soon as your application begins to scale and you run into challenges with performance where parts of your application are not responding quick enough, then where are you going to go? What database are you going to choose? And it turns out Redis dominates that next category. So while when you're building your app and you're just getting going is not most often Redis, there's a lot of options there, including Redis. That next step, when you start to scale and all of a sudden you need lots of help with one or two parts of your application and maybe many more parts of your application, most people will turn to Redis. And so Redis actually is about, according to some, about 16%. So 13% MySQL, actually 16% of the usage on AWS is actually Redis. So good examples of this would be like for example, Twitter. Twitter has thousands of Redis instances. That's far more than anything else they have. And some companies that you may not know about, but like Snapchat, about a year ago I heard they were re-architecting, I don't know if they need to do this now, but they were re-architecting to have about 100 terabytes of data in Redis. 100 terabytes. So, and there's, like in China, forget it. It's just massive, massive Redis everywhere, all right? So once you get to that point where you're scaling, there's, especially in the consumer web, It's just massive, massive amounts of Redis. And for example, Lyft gave a talk. I think they were using, I think it was 2 years ago. I think they had like 800 Redis servers. Okay, and you hear these stories over and over again where they're using hundreds of Redis servers because all the stuff that the consumers are doing needs to be fast, and Redis is basically built for that. It's built for those very fast use cases. Now, there's lots of different ways you can do this. And I'm sure you can use other systems too, but routinely, for the breadth of interactions that you have with consumer-based web apps, Redis is going to be the right choice for you. OK, so in fact, there's a really funny, interesting story. There's this company called Iterating, and they have a game, which I'm forgetting the name of it because it's in Portuguese. It's sort of like Words with Friends, but in Portuguese. And they started off on our cloud. Redis Labs has a cloud-based service that runs on multiple clouds, but it's a multi-tenant service called Redis Cloud. And if you go sign up there, you can get a free account. We're never going to charge you for it. It's free, up to 30 megabytes of memory. So it's not a lot, but you can get started. And as long as you keep using it, we're going to leave it on and won't charge you. And so they started off with one of those, and then the game got very popular. It just grew and grew and grew very rapidly. So at some point, they were up around 10 terabytes of data for a game that just very, very quickly became the most popular game in Portuguese. And the whole thing, they were just using Redis, the whole thing. And why? It's because when you have consumer-based applications, especially games and things like that, if you have a delay in the application long enough for another thought to enter your mind, you're very quickly going to get distracted and go do something else. So when that company's growing and they're very quickly trying to get users to have more funding or revenue from ads, you can't have that pause, that delay, because folks will get, oh, this is a game, I don't need to be doing this. What else should I be doing? They're off in something else. So just use Redis. All right. Now, what are the differentiators? What makes Redis special? Well, first of all, it's performance. Okay, it is extremely fast. There's really nothing else out there that is so free and so widely used that gives you so much such a low response time and throughput. It's extremely fast in response time. It can operate at around, well, I'm not sure this would work for everybody out of the box, but you can get it to about 1 million requests per second. And that's like half reads and half writes. And we do things like pipelining, which means we'll, instead of taking 1 million requests, sending them one after another, we'll pipe a whole bunch of them together and send them over so that you're not wasting time on the back and forth, because that's what kills you is the network traffic is, even if it's just a millisecond, that's going to add up, and it's usually more than that. So, so pipelining helps dramatically with that. And then again, to reach the performance that we offer, that you can get with Redis, you can actually do it in fewer numbers of servers. So it's going to actually reduce your amount of effort as well. Now again, you can slice and dice numbers all day long in different ways, but really at the end of the day, the proof is in the usage. It's extremely popular for this reason. Now another thing that's pretty cool about Redis is, anybody can tell which movie this is from? Anybody? 2001. Yeah, it's actually 2001. Actually, trick question, because it's actually 2010. They're kind of reflecting back to 2001. But yeah, it's 2001, A Space Odyssey. And I like this because, they have the monolith, in space. They're looking at this black monolith, was it like 1 by 3 by 9 or whatever. And he's looking inside of it.
1 by 4 by 9.
Is it 1 by 4 by 9? Thank you. All right, we've got some fans. He's looking inside of it, and he sees stars. Well, Redis to me is kind of like that, because on the outside, it's just this key value. You don't really think about it more than that. But the reality is inside it's got all these data structures. And the data structures are spectacular. It makes Redis very unique, and it makes Redis very special. Because not only is Redis an in-memory key value store where, it's very fast because the data is in memory, and it's just a key. So the entire thing is one giant index of keys, right? It's just one index. There's no looking for another sub-index or anything like that. It's just a giant index. That alone makes it very fast in memory. But the value is not so simple. The value depends upon what type of data structure you're using, and there's 10 different data structures. So it's not just a key in a string. It could be a key in a hash, which is really a string cut up into field and values, but it could also be a list, which you can use as a queue. Okay, and it goes on and on. Here, I'll show you. There's yeah, here they are. So it can be a list. It can be a set, which is, again, a key and then a bag of unique values. And you might wonder, why would I want a bag of unique values they're not ordered? Well, what if all you care about is just storing like unique IP addresses to your website? You basically have the ability to just throw the IP address at this data structure, and it just ignores the duplicates for you. Okay? Or if somebody's tagging a product in a category, and they throw a bunch of keywords at this thing. Well, you just throw those keywords at it, and you just ignore, again, the duplicates. You just keep the uniques. Very, very simple and very, very fast. And you can do some really cool things with it. For example, you can take a list of everyone's friends. Like when you go to like Facebook or something, it says, here's your mutual friends. You can take your friends and their friends and very quickly they're in sets, very quickly merge them together, and you get the unique, you get the intersection very, very quickly. So you don't need to like pre-calculate this ahead of time. You got sorted set. Sorted set is also extremely unique in that I don't think there's another solution for this. If you're running a massively multiplayer online role-playing game, you know, you've got, I mean, some of these have like 10 million simultaneous users. How do you keep that score in memory? You know, the scores are constantly changing. How do you do that? Like, you're not going to do that outside of memory. There's no way. It's going to be in memory. So you use a sorted set for that. You basically have, similar to a set, where you have a key, and then you got a bunch of usernames or unique values, right? And then each one of them has a score. And the scores can be duplicates, but that score in real time, they're changing, right? So your 10 million person leaderboard is changing in real time. And you do that with sorted sets. Netflix uses something like this to track all of they have like, what is it, 1 billion API calls per minute, I think they said, or maybe it's more than that, I don't know. But it's at least 1 billion per minute. They take every error message and they throw it at a Redis leaderboard. And that way, if there's a duplicate error message, it increments. And so the most popular ones rise to the top very quickly. And that's how they figure it. That's how they know what to troubleshoot. Just goes to the top. So after sorted sets, then you've got some other interesting ones like a bit array, okay, or what do we have it called here? Or a bitmap, yeah. Bitmap is basically a bit array. It's a key and then an endless number of ones and zeros. Okay, you might, well, what do you use that for? Well, what you can do is you can take every single one of your users. Let's say you've got 200 million users. Pinterest did this at once. I don't know if they still do it, but at one point they had 200 million users. They stored, and each one of those bits is uniquely addressable. So you store the address to one of those bits in your user profile. And you store all of your friends' IDs in your user profile. So when you log in, you go to your user profile, look for your user friends, get all of their uniquely addressable addresses, and then go look to find out, is that user online or offline? So you basically have one key with 200 million ones and zeros. And that takes about 25 gigs. So stick that on one server, and that becomes a microservice to tell what the on or offline status is of all your users. You ever wonder how they do that? That's how they do it. It's extremely fast. And you add pub/sub to that, and now you've got all your users out there logged in, and they got the little green and red stop sign signals. Are they online or offline? And every time something changes, it fires off the message to go and update all the clients to have that little message there. So try to do this in another way. I'd like to hear someone come up with another way to do this. We also have a bit field, which is instead of ones and zeros, it's numbers. So you can have like a massive amount of numbers. This is great for storing metrics, things like that, very fast, ingesting large amounts of metrics. You got geospatial index. This is, I think, what Lyft is using it for. So that when you're looking at the phone, you see all the cars driving around on your phone. They're using a geospatial index to find out which cars they display there. And that's a pretty cool one. It's actually based on the sorted set data structure, but they threw the geospatial, I guess it's called a geocode or geo hash, one of those two, I forget. But you can take a latitude and longitude and you can convert it into an index. So it's just one giant, index of values. It makes it very quickly easy to search what's nearby. And you got hyperlog. So there's some hyperlog is what we call a probabilistic data structure, and what it means is you can take all of the words, the strings, the text from the entire web, all of it, and you can figure out. Let's just take Wikipedia to make it simple. You take all of Wikipedia, and you want to know how many times does the word Redis show up in Wikipedia. Well, if you're just doing a quick search, like on Google, like a normal Google search, and you search on for the word Redis, I think it's going to show up like, I don't know, 4.5 million times or something. And it's going to say 4.5,000,000. Okay. Well, is it really 0000? No, of course not. But do you really care? I mean, that's the number. That's good enough, right? So if you want an extremely fast way to look up and get a rough estimate of how many times a word appears in a very large body of text, you can use a hyperlog, which basically uses ones and zeros to statistically count how many times a word appears, but it's an estimate. It's not perfect. But the beautiful thing about it is that it crunches down into about 12K. So you can literally take, just terabytes and terabytes of data, something that you might do like a Google search or something, and crunch that all down to 12K, and store that on all of your servers so that you can get that number immediately, very fast. So very, very cool things you can do with Redis. One of the most recent ones that's actually due to come out this month is Redis Streams. So Redis Streams is not out officially yet. It's in the release candidate 5. We're hoping it comes out in October. It all comes down to Salvatore. But it's looking promising. And Streams is essentially kind of like a time series or a log, all right? But it's a great way of storing information that you're ingesting. There's a lot of different use cases, but it's kind of like Kafka, right? You got all this data coming in, and you want to be able to process it, but you want to know the order that it came in, and you want to be able to pull the data out of the stream and know in what order and who is pulling the data out of the stream. So there's a lot of complexity around this very simple thing of essentially ingesting a log. Okay, now Redis, so those are the Redis data structures, and really, I'll come back to some of these in a little bit so you can have some idea of the use cases, but really that's the power of Redis. However, just like geospatial is built on top of sorted sets, I think Salvatore started realizing, the number of things that people want me to build now is starting to grow exponentially. And I can't build everything. It's just impossible. In fact, Redis really shouldn't be everything to everyone. But how do I meet the needs of those who need something to run in something like Redis, but it might be special to their use case, or maybe there's just a very small percentage of people who want it. I think the hyperlog is kind of like that. He built that, and then people were, why don't you build a Bloom filter? A Bloom filter is very similar to a hyperlog, but instead of telling you how many times a word appears, it tells you if the word appears. So it's even smaller, and it tells you for sure with 100% accuracy if the word does not appear. But if it says that it does appear, then you're not 100% certain. So then you have to go look it up, which is absolutely great for things that are rare, because you can see, is it there? No. Is it there? No. Is it there? No. Is it there? No. Is it there? Yes. Okay, let me go look it up and confirm, right? So. But he's like, well, okay, do I build a hyperlog, Bloom filter? There's all these variations. I can't do everything. How about I built a module system so that you can build your own custom code. You can even build your own data structures that will run in Redis as first-class citizens, but it's your custom code. And I'll give you a very simple way. You literally just type load and then the link or the location of the file, the module, and it loads it up into Redis, and now it's running as a first-class citizen in Redis. So it's very easy to do this. Here are the ones we have right now. I think there's a few more, but this is the most of them. Redis search has actually become fairly popular. So if you're looking for somebody, like what do people use Redis modules for? Redis search is become quite popular because Certainly Redis has all the data structures you need for search, but to do search where you're looking for specific values or then values within in text, it actually is quite a bit of mixing of data structures and code. And so to do that effectively takes a lot of work. And so they built Redis Search to really put that all into one very efficient module, which you can now use. And it's very similar to like Elasticsearch. Redis ML gives you machine learning capabilities. Redis Graph gives you the ability to do like a Neo4j type graph. ReadJSON is sort of like MongoDB. It's a JSON document. And then there's others. So pretty cool if you're looking for some capabilities. I think Redis Cell, I'm not sure why it's called Redis Cell, but I think that's rate limiting, so on and so forth. Okay. So I just quickly wanted to shout out that Redis is becoming extremely popular in microservices. I think part of the reason why is that microservices are fairly chatty. By the way, if you're ever wondering what the difference is between SOA and microservices, if with your microservices you have to change other microservices anytime you change one microservice, that's really not microservices, that's SOA. That's my joke, by the way. But if you're changing any one of these, but they have dependencies and you have to change the others, it's really not microservices. Microservices is more like this. This is from Netflix. You've got so many out there. There's no way that you should ever have the dependency to change multiple microservices just because you're changing one. You basically have to think of all of these as individual products, and you have to have many versions for each one of your microservices. And you have to think of all the consumers of your microservice as if they are a customer, and you have to notify them, hey, I'm adding a new version. You can now use this version. I'm going to end of life the old version in 2 years, something like that. Okay. So, but it's very, very, very chatty. And so Redis becomes very important. Netflix uses a massive amount of Redis. Massive. And then I like to joke about microservices. Everyone thinks that they're using, they should be using microservices today. Everyone makes arguments why you should. There's lots of good reasons why you should use microservices. But really, start off with a monolith, please, and then figure out if you really need microservices. But I mention this because Redis also turns out to be an excellent bandage. So let's say you start off with a monolith, and it starts to catch fire. Okay. Parts of your application, not your whole thing, parts of it will start to fall apart. Parts of it will not scale. Take Redis and use it for those parts. It gives you time to then re-architect your application, perhaps into microservices, but you can use Redis to give you that time to make those decisions that you need to make about your architecture. And then, of course, once you do re-architect, you're probably going to use a lot more Redis. But good example of this was with Twitter. Twitter was falling apart. I don't know if you remember the early days of Twitter, but the fail whale. Okay, well, how did they solve those scalability issues? They used a lot of Redis. And then you see a lot of Redis now with the Kubernetes ecosystem. Why? Because, again, you're moving to this microservices architecture. Things become very chatty, and Redis runs great inside of there. You'll see lots of these like Death Star diagrams now with people, people showing off their microservices architectures, and the reality is that Redis is just all over these things. So, yeah. So let me give you a couple use cases, and then I'll get into streams. First one is just as a simple cache. There's really two types of caches, but a lot of people just stick to the simple one. The simple one would be what we call a look-aside cache, and that's where this is kind of that situation where you got your monolith, and you have, let's say, a product catalog. And let's say you're Walmart, okay, and you've got 2,000 applications out there that are constantly looking up your product catalog. They might have, I don't know, they might have 1 million requests per second, okay, because they have so many applications out there and consumers looking at this stuff. Well, are prices changing every second? Of course not. Well, some place they might be, but probably not the one that you're looking at every minute. So it makes sense that you would just cache that somewhere. So what you do is you simply, when a system actually needs to update your product price, and it's not just price, but it's also quantity, like is this thing available or not? When those change, you can write through to the database. Let's just say it's some SQL database. But then when your and so you're not talking to Redis at that point. But then when you're looking up those values, you first look to Redis and see, do I have the most recent value? And then you give yourself some sort of timeout, right? Like, for example, I might be comfortable with a 10-second delay, or being out of date by 10 seconds, or a minute, or an hour, okay? And so you keep, if you don't find the value in Redis, you go look it up in the SQL database, pull it back, stick it in Redis. Now you got that quantity or that price in Redis. And now for the next, excuse me, 10 seconds, minute, hour, whatever, you look to Redis first and you get the value out. And then you save yourself a bunch of time, your SQL database is not getting crushed, and everyone's happy. There's another one called a write-through cache, where you actually write to Redis and the SQL database at the same time, in some sort of transaction, so that you know that you have the values in both place at the same time. So there's no point at which you're looking up in Redis and the value is inaccurate. Okay, so you can do that with a multi-function in Redis, so you know that you're getting it's going through and completing without being out of sync. So those are the two different ways people use cache. Redis as a session store. This is turning out to be very, very popular. With our own customers, this recently passed being used as a cache. This is now the most popular use case for Redis. And that is, does it make sense to store whether a user is logged in or not to their session in an SQL query? That makes absolutely zero sense. It's a key value lookup. It's user ID, lookup, yes or no. Okay? And of course, you can put some other values in that string as well. But there's no reason to run a query. Like it's a very inefficient use of a SQL database to be looking up session login information with a query language. So it turns out that Redis is in memory. So super fast. Do you really want, is this user logged in or not, to be slowing you down? Of course not. Get it out of the way. Make it fast, simple, easy, inexpensive. Your SQL databases usually cost a lot more than anything you're going to spend on Redis. So it's just the perfect place to put it. And so Redis has an automatic session timeout. You can specify when you set the session, hey, the person's logged in, throw their data in Redis, specify a timeout of 20 minutes. And then Redis will automatically delete that key after 20 minutes. Very, very popular use case. It's very simple. I mean, I'm just going to go through this really quick. Most people start off with some SQL database for using their sessions, which is great until you start overloading it. And then like, okay, well, what I'm going to do is I'm going to store the session on my server in memory. So a lot of .NET programmers do this. They'll start storing it in Redis. In their .NET and C# on their server. But that's a problem because as you get more internet traffic, now your server starts to struggle. What do? You add more servers. Wait a minute. My session is stored on one of those servers. That's great, but now the user comes back and they're using another server because they have a load balancer. Oops, that didn't work. So what you do is you stick Redis out there and you put all of your session information there. Yes, you do have to go across the network, but again, with pipelining and things like that, you end up getting just about the same amount of response time, but you get all the throughput. So you end up not really having much of a performance hit. And to give you an example of how this works, just so people, those of you who are interested, Redis is a bunch of functions, okay, or commands. I don't care what you call it. A good example here is HMSet. That stands for hash multiple set. I want to create a key called user session :1 with Redis because it's just one giant namespace of keys. It's kind of tricky. There's no such thing as table and then a collection of keys inside the table, right? We don't do it that way. It's one giant. So you can kind of think of the name user session as your table name. Think of it that way. And then colon, and then the value after the colon would be like your index. So this would be an index of user 1 inside a user sessions table or collection. That's mentally how you might think about it. And then what we're doing is we're setting up multiple fields. So user ID is my first field. There's the value, 8754. Name is the second field. Dave is the value. IP is the third field. There's the IP. And then hits is the fourth field, hit 1. how many times did I come back? Now get, I can hm get. I want to get multiple fields back, user session from user session 1. And I can also use h increment by. So hash increment by, and I want to increment my field hits by 1. Okay, and then it's going to keep tweaking that. Redis is extremely focused on performance. So anything that can be done to increase the performance of that function, you can find. It's amazing how, hey, I only need to get back one field name. Well, just use hset to set it, and hget to get it, and you're just going to get back that one field. So it knows how to be. You'd think, well, that's basically the same thing. No, it's actually more efficient to do it this way. Okay, and because again we're focused on performance, it will do that. And there you can delete a key or you can delete a field. All right. Metering. Redis for metering is another very, very popular use case. You will find folks again in like that. I kind of mentioned Walmart. It wasn't actually Walmart. It was Home Depot, I think. So anyway, they had. Oh yeah, there you go, Home Depot. So they had their data in their SQL database somewhere, and they had these thousands of applications hitting it, and they found out that they were having these crazy spikes because for some reason, certain times of the day, it was a little bit unpredictable, but they'd have these crazy spikes. And so they said, well, we don't want to stop anybody from accessing the data, but what we do want to do is put a rate limit, which says you can call this data a certain number of times per second, and if you call it more than that times per second, we are still going to respond, but we're going to buffer your request, and then it's going to actually come back a little slower, and that way we can handle the spikes. And so what they did is they put Redis in the middle in their data access layer, and every single request to the SQL database went through Redis first to actually check to see how many times the application had made a request. So that becomes a rate limiter, and because Redis is so fast, didn't impact their performance, and then they were able to actually provide the quality of service that they were looking for using Redis as a rate limiter. For fast data ingest, so Redis has been used, actually its very first use case was fast data ingest, really. Basically, it was trying to Salvatore was trying to dump, I think it was like 100,000 writes per second into MySQL, and he couldn't figure, this is nearly 10 years ago, he couldn't figure out how to make it scale. So finally he gave up, and he said, well, I'm going to put something in memory, and I'm just going to queue up all these things, because he knew that that MySQL could handle the load if you batched the load up and then dumped them into MySQL 10,000 records at a time versus one at a time 10,000 times. So that's actually how Redis got started, is ingesting. So it's very good at ingesting. He was using the list data structure to basically create a queue. And so that's a very popular scenario. This can be used for real-time analytics, IoT, log collection, all this kind of stuff. It's also used as a part of other capabilities like PubSub. There's lots more you can do with Redis. I just gave you 4 examples. I'm going to give you a couple more, by the way. But so you can use Redis. By the way, use it as a primary database. Redis will save data to disk. People don't think of that because they think, oh, it's in memory. It's only a cache. No, it is absolutely saving data to disk. It's literally just a configuration change in your config file, and you set it to save to disk. Okay, and what's going to happen? It's going to save the disk. Is it ever going to read from disk? No. You don't need to read from disk. You're always reading from memory. But if you want to make sure that if something happens, you shut down your server, you have a failure, anything like that, when you boot it back up, it'll pull all that data back from disk and put it in memory, so you didn't lose anything. Now, the way to really do this, by the way, and to do this at massive scale and to never lose your data, and I can tell you this with confidence because as a company, we have been running I think we run Redis as a service on 4 major clouds, and I think we've launched over 800,000 Redis databases for customers. I think we have 50,000 running right now. And while we have had some failures, it's always been because of cloud vendors. And we have failures all the time. There's always cloud vendors, virtual machines, or containers, or whatever are failing. And yet we don't lose data. How do we not lose data? Because what we do, and we recommend everyone do this because this is how the cloud how it was meant to be used. Instead of writing to disk, what do? We write across the network to another Redis. So you actually get to do things very fast this way. It's actually faster than writing to disk. So you have your master and then your replica. Okay? So you get written into the master. You write to the replica. Replica responds back to the master, says, I've got it. You respond to the customer. Now you got your data in two places. The replica then writes to disk. All right? Now you got all your data on disk, and you've got it in two places. If either one of these go down, no problem. If everything goes down, you get your data. Now, this turns out to be extremely efficient because guess what? If you're using some database that says, oh, I'm going to write to disk, like most SQL databases will do, they say, oh, I'm going to take your data. Don't worry, I got it. I wrote to disk. You're in the cloud, dummy. That's not disk. Okay? There's no disk there. If you do write there, you're an idiot because that could go away at any moment, and you've just lost your data. So you're going to write across the network anyway. But they're doing some funny business down here because there's some sort of cache down there, and you may not actually have written to disk. So the way to do it is explicitly take advantage of the way the cloud was meant to be used, write across the network. You know you now have it in two locations, and then write to disk. Everything's safe. You haven't lost the thing. And that's why we don't lose data. We're doing it the way, the cloud-native way. All right? And if you are using a product that says it's writing to local disk and you're doing this in the cloud, double check that, okay? Because it might not be behaving the way you think it should be. All right, so there's lots of other use cases. Quickly, the leaderboard one for sorted sets. Let me just show you how that works. Again, zadd, these are all functions, like I said before. Zadd, this is how you write your key is going to be game 1, okay? And then you have this, you might just have one game. And you might have 10 million users in there, okay? So then you have over here, ID 1, set it to 10,000. Okay, so now your user ID 1 now has a score of 10,000. All right, and then as you go through and make these changes, you're basically either updating the users directly, or you can use z increment by, tell it that for user ID 3, I want to increase that by 10,000 points. Okay, and you can then go and get ranges. So is it interesting to know who the top 10 players and their scores are? Sure. But to an individual user, what's more interesting? To know what their score is and who's above and below them. All right, and again, we got 10 million users and everything's changing very quickly. That's very difficult to just go find somewhere in there in real time what the score is for 10 users above and below you, right? So Redis can handle that, no problem. All right, so let's talk about streams, because that's really what I think a lot of people are here for. Streams, like I said, is not available yet. Redis Streams, Salvatore decided to make it as a first-class citizen. So this is not a module. He could have built it as a module, but he has a lot of experience with queues and this kind of thing, and he realized that this really needed to be written as part of Redis. So it's a first-class citizen. It is a data structure. So think of it as a data structure, and you're basically just adding in row after row after row after row. Okay. So it's an abstract data type, so you can put any types of logs or other information in there, but it is very much like a log. And it's designed with understanding time series or time series data very carefully, because when you're writing so much data, you can't just increment by second or fraction of a second. You have to be very careful. It's very easy to write data into a queue or into a stream where you set a very, very detailed timestamp, and you still get duplicates. Okay, so how do you handle those kind of things, right? So these are all part of the considerations. It is sort of Kafka-esque. It's kind of Kafka, but in a Redis way, the way Redis thinks and behaves. So, but you can think of it very much like Kafka, although today it does not have all the functionality Kafka has. Kafka's been around for quite a long time. However, Redis will have certain benefits that Kafka doesn't have, primarily because of the way Redis behaves. So you might ask, well, why rebuild? Why build something new? Why not just take advantage of what's out there already? Well, Redis has the ability to do ingestion today. You can use sorted sets. You can use lists, and people do actually use Redis to store information like this already. But there's always been sort of you've always had to cut corners or not quite do things quite right because, for example, with the if you use sorted sets storing your log data, you're now having to kind of make up that timestamp yourself. And sometimes you actually want the service to make the timestamp for you because it knows its own time, and you don't want to have people duplicating a timestamp. Okay, so there's a lot of examples like that. You could put it into a list, right? But then a list is very easy to find data at the beginning or the end, but it's very hard to find data in the middle because there's no index. So that's not ideal either. So you could take advantage of Redis already to do this, but it really needed to be something specific. And logs are not new. So logs have been around, so it's nothing a new thing. But again, there's all this logic specific to logs that were not available already. So it had to be made up again from scratch. There's a lot of semi-structured data as well, and so where do you store that data? If you're using a sorted set or a list, this data doesn't really have a place to go. You have to then store it in another data structure, and then that ends up complicating things and actually taking up more overhead than you would normally want. And by the way, let's talk about distributed systems. This is, by nature, going to most likely be used in a distributed way. So now you have things that are coming into factor that maybe you hadn't thought of because distributed systems are complicated. Here's a quote from Wikipedia. A distributed system in which components located on a network computer communicate and coordinate their actions by passing messages. So not only are these special use cases, they're quite popular. This kind of communication is used a lot. It's used in client-server, end-tier architecture, peer-to-peer, services-oriented architecture, microservices, I guess nanoservices. All of these systems are distributed and need to talk to each other, and Redis can be used now in a preferable way for these use cases. By the way, so there are really only two hard problems in distributed systems. One, exactly once delivery, okay, guaranteeing the order that those messages are delivered, and then exactly once delivery. All right, that was a joke, by the way. Sorry, I didn't prepare you for that, but that was a joke. But it is hard to do both of those things at the same time. So it's actually pretty easy to say, okay, I want to deliver something at least once, or I want to deliver something no more than once. But to say I want it to be delivered exactly once in a distributed system is actually quite difficult. And then especially if you're throwing on top of it, okay, now I want these to be in a particular order. That actually becomes very difficult. So usually when you deliver messages, you can, I just said this, by the way. So you have at most once delivery, at least once delivery, and exactly once. I mean, yes, you build the systems to behave that way, but it's kind of like the CAP theorem. You just can't really guarantee that. Okay, so it's not an exactly new challenge. There's all these other systems out there that are behaving similar or provide similar functionality, whether it's products that store the data or the libraries that create these kind of systems. So there's a lot of them out there. So again, why reinvent this? Well, Redis should actually be very good at this. Redis is actually very small, so you can actually, without any data in it, it's only 3 megabytes, so it's pretty small. You can fit it out on IoT edge devices, not just the edge itself, but edge devices. And it runs everywhere, so it's pretty available. It's good. Redis is a good place for streams. And so I actually need to skip ahead here real quick. So just real quick, like a picture of a stream, because I'm running out of time here, but so you got your picture of a stream here, and then you got consumers. So Redis does have the concept of consumer groups. So when you create a stream, you can then divvy up the workload into different consumers who can pull out the data and then process that data. And that's, when you're dealing with scale, it's very unlikely the amount of data going in is coming in at the same rate at which you can process it. So you're either going to have large amounts of data coming in, and then you have one processor consuming it, or you're going to have some, I'm sorry, I said it wrong, slow, not that much data coming in, I'm sorry, and then maybe one consumer of it. But if you have a lot of data coming in, then what happens is if the data gets processed at a higher rate than each stream coming in, then you may have fewer consumers. If it gets processed at a slower rate than it's coming in, then you may have more consumers. So you have to balance based on how much effort it takes to process the data. Okay. Again, entries in the stream, you have a unique ID, and that unique ID is usually captured in milliseconds plus some sort of sequence, because it just gets impossible to try to take that time and just put it into more and more decimals, decimal places. That doesn't work because you end up duplicating things when you didn't intend to. So you can have a timestamp plus a sequence, and that ends up being unique. Okay, here's a quick example of how you might create a record in Redis. So xadd is going to be the function, and you're going to have the key. So the key is basically like your stream, right? And then you can specify either your own timestamp yourself, which would be like the ID, or you can specify an asterisk, and that asterisk tells the server, please you create the timestamp. All right, then the time that can be, it looks more accurate that way. It's more consistent. You can specify the length, and then you can specify the number of fields. Okay, and you can bunch them all up together too. So you can actually have many field value, field value, field value. So if you want to send a bunch at one time, you can. You don't have to say, here's the first one, and then make another call, and here's the second one. So there's a lot of effort been put into this to make this extremely efficient, and I think he's done a pretty good job. I mean, I'm not an expert in this kind of stuff, but from what I can tell, this is not goofing around. This is serious business, and he's put in the effort to make it serious. You can query the data, pull it out. You can and iterate through it, okay, which is very important when you have large amounts of data. You want to know, where did I leave off, okay, and how do I come back. You can read the data and block it so that others are not reading from it, so that you know who got what, all right, so you're not pulling data out. And then if you need to do multiple things at one time, Redis has a built-in multi-function, so you can. A lot of people don't know this about Redis, but it's actually single threaded, and for a reason, because it's single threaded, you don't have to worry about blocking in the way other databases typically do. So if you go to write and change a record, and then you try to do something else and come back and read it, you'll know that it will be exactly the way it was. You don't have to lock that record, because if you're multi-threaded, you do. You have to worry about those kind of situations. With Redis, you don't, but you do have the ability to do something called multi. So if you want to perform a function, a command, but you want to make sure that they happen in a particular sequence without another command coming in and disrupting it, you use multi, pass all the commands in at one time. They will get done in the order that you specify. Okay. Okay, so I am out of time, I think. It's supposed to be done a minute ago. So consumer groups, yes, we have consumer groups, and there's lots of commands that help you orient your groups, and I'm out of time. So it should be available this month. If you want, I can share with you some of the code that I've been demonstrating. This is just simply code that's taking Twitter, and it's just taking data out of Twitter and just dumping it into Redis Streams, so you can kind of see how that behaves. And this is in Java. I'm happy to share with you what we've got. The client libraries mostly support it already. But right now, Java, Node.js, Go, I think. Some of the client libraries already support Redis Streams. Some of the others have less support. But if you have any questions, or if you want any more information about it, please contact me, or just get started with Redis yourself. You can go download it from redis.io/download. Make sure you download the release candidate 5, not the version 4. And You can run it in Docker as well, or let me know. And I didn't put my email address here, I should have, but I'm dave@redislabs.com. All right, thank you very much.